Welcome. In our previous videos, we've discussed SQL from the perspective of data retrieval, or retrieving data stored within a database. That is, what we've looked at has been the SQL select statement. We're now going to expand a bit our discussion and look at the idea of performing what's called data manipulation. We'll look at how to add new rows to a database table, how to take existing rows and change the value that's stored in one or more columns of those rows. And we'll also look at how to remove existing rows from a database table. So let's get started. This brief video is guided by a simple set of objectives. The overall goal is to provide you with sufficient information so that you can populate tables that you may have created and perform additional DML operations as needed. What we plan to accomplish in this video would be to give a brief introduction to the data manipulation operations available in relational systems. We'll discuss two forms of the SQL insert statement, and we'll also explain the importance of giving close attention to set-level processing for data manipulation statements, in particular the update and the delete statements. Data manipulation is primarily accomplished through three SQL statements: insert, update, and delete. Because we wish to provide a quick overview of data manipulation, we'll limit our discussion to just these three statements. Insert is used to add new rows to a table. Update is used to modify the value in one or more columns of one or more rows within a table, and delete is used to remove existing rows from the table. We'll consider two forms of the insert statement. In the first form, we'll see that we can put exactly one row into a table. We'll be taking data from outside the database and placing it within an existing database table. In the second form, we'll take data from multiple rows that are already present in some database table and insert those rows into another table. In the following statement, our intention is to add one new row to the course table. The name of the table immediately follows insert into. The table name must correspond to some previously created table. We then have a values clause, and the values clause introduces the values to construct the new row. These values are listed here as comma-separated values contained within a set of parentheses. In this form of the insert, there must be one value for each column of the table, and the values are specified in the table's default left-to-right column sequence, which was established in the create table statement. The drawback to this approach is that it requires that you know the left-to-right order of the columns in the table. In the next slide, we'll consider a friendlier form of the insert statement. Our next example presents a slightly friendlier version of the insert statement we just examined. In this version, we have listed the names of columns for which we will provide values. While this list consists of all columns in the course table, it's easier to see into which column of the table each value in the values clause will be stored. One advantage to this extended syntax is that we are able to list column names in any left-to-right order. In our next example, we still provide a value for each column, but we've changed the order in which these values will be provided. All we need to be sure of is that this order of values in the values clause align with the order of columns as we've indicated them in the column list. For a table that has been defined with columns that have a default value, there's an additional benefit to using this syntax. For any column that has a default value, we can omit that column from the insert statement and the system will populate the column with the default value of that column. For example, if a column does not have a not null constraint, the column automatically has a default value of null. In our next example, we illustrate a technique for inserting a row with only some values. We've not specified the credit and the lab fee columns. These allow null values, so those columns will be set to null. The examples we have presented illustrate how a single row can be placed in a table. But before we go on and look at the second version of the insert statement, let's consider the data integrity. Not null is a type of check constraint. A column declared with this constraint must be provided a known value, that is, a value other than null. If we attempt to place the null value in a column defined with the not null constraint, the system rejects the operation by raising an error. If we modify the insert statement for our final example here, where we attempted to insert course number C78, and if we fail to supply a value for either C description or C department, omitting the column name from the list and a value for that column from the values clause, the system will attempt to place a null value in the column, and this will raise an error because there's a not null constraint defined on the columns. Entity integrity refers to the requirement of a unique identifier for a row, that is, a unique primary key value. CNO is the primary key of the course table. In the first three examples that we've shown for the insert statement, we used C77 as the value for CNO. Note that we could not successfully execute all three of these statements because we would be violating entity integrity. At most, one row in the course table can have a value of C77 for CNO, the primary key. Referential integrity refers to a parent-child relationship between two tables. This relationship is defined by a foreign key in the child being restricted to values found in the primary key of the parent. In the course table, C department is a foreign key. Our examples have used the value of CIS for this C department column. Given the relationship that we've defined in our database tables, this value must be present in the primary key of the parent table, which is the department table. Furthermore, we could not omit this value because C department is defined with a not null constraint. Thus, execution of DML statements depend on abiding by integrity constraints in the database. These constraints fall within the realm of declarative integrity. Note that if a database table has associated triggers, a form of procedural integrity, DML operations must also follow the business rules enforced by these triggers. Another form of the insert statement allows you to take data that is already present within some database table and use that data to construct new rows to be inserted into another table. In this example, we assume that a table named CIS course already exists. The select that follows the insert into CIS course line of this statement will extract four values from the course table for all of the rows where C department is equal to CIS. So we will have a set of rows. These values are then inserted into the four columns that define the CIS course table. Thus, CNO from the course table must have the same data type as whatever the first column is in CIS course. CNAME must have the same data type as the second column in CIS course, and so on. Having seen these two forms of the insert statement, you should now be well equipped to add new rows to a database table. Let's now consider the update statement. The update statement allows us to change the value in one or more columns of one or more rows that already reside in some table. The update statement begins with the keyword update followed by the name of the table whose rows will be updated. A set clause is used to identify the columns to be changed and also includes the new value to be placed in the column. The where clause is extremely important when using an update. Think back to some simple queries that we looked at. If we were to say something like select asterisk from course and omit the where clause, every row from the course table will be returned. If we do an update and omit the where clause, every row in the table will be updated, exactly as we've specified according to the set clause. So the where clause must be very precise and very specific in terms of identifying the single row or the set of rows to be updated. Again, omitting the where clause causes every row in the table to be affected by the update. Our first example is showing us how to change the lab fee value for course number C77. Recall that CNO is the primary key, so this update will target at most one row. The value that's currently in lab fee for course number C77 will be replaced by 175. It's also possible to update multiple columns with a single update statement. We use a comma between the changes in the set clause. We demonstrate this with another example. Here we're updating the row in the staff table where the employee name is Mo. We set the e-salary to a new value, and here instead of a constant value, we have an expression that will be evaluated, and the result of evaluating the expression will produce the new value to be placed in the e-salary column. Notice the comma that follows this clause. We then have another column and another value, and then a comma, and we continue on until we've identified all of the columns that we wish to update with this statement. Now, in our staff table, e-name is unique. We can have at most one employee named Mo. So again, this update will target exactly one row. And a final reminder, if you omit the where clause, everyone would suddenly have the same salary and the same job title and be employed in the same department. So be very careful when using an update statement to ensure that you have the where clause to identify specifically the row or rows that you wish to modify. The delete statement is used to remove one or more rows from a table. It removes the entire row. You can't really delete just a column or a group of columns. The entire row is removed from the table. And again, the where clause will identify which row or rows will be removed. If you omit the where clause, every row in the table will be deleted. Be aware that if a table has associated delete triggers, executing the delete statement will cause these triggers to fire. If it is your intention to empty the table and you don't wish to have the delete triggers fire, consider using the truncate table statement. Furthermore, note that if the target table is involved in a parent-child relationship, referential integrity will be enforced. In the academic tables that I use, CNO is the target of a foreign key reference from the class table to the course table. Thus, if the rows to be deleted currently have matching rows in the class table, the delete rule declared for this relationship will determine whether the identified rows from the course table will actually be deleted. With this brief video, we have given you sufficient information to perform basic data manipulation operations on your tables. You should be able to add new rows to a table, update existing rows, and remove rows that are no longer needed. I hope you found this video to be useful and informative in getting started with data manipulation.